This is lesson 2.2, solving inequalities using addition or subtraction. The essential question there is, how can you use addition or subtraction to solve an inequality? Well, just as you use the properties of equality to produce equivalent equations, you can use the properties of inequalities to produce equivalent inequalities. Equivalent inequalities are just inequalities that have the same solutions. So your core concept here is just adding the same number to each side of an inequality produces an equivalent inequality. So let's look at our first example, solving an inequality using addition. What you're going to do is you're going to solve much like you would a regular equation. So we have a minus 6 over here. We want to get the x by itself. So we do the inverse. We add 6. Whatever you do to one side, we're going to do to the other. Those will cancel out. I'm left with just x over here. You keep the sign, greater than or equal to, and negative 10 plus 6 is negative 4. So that's going to be the equivalent inequality. Now we just need to graph it. I'll just mark this as negative 4, negative 3, negative 2, negative 1, 0, 1, 2. So it is going to be a closed circle because it's got an equal sign. So we're going to put a closed circle at negative 4. And then we've got to decide x is greater than negative 4, which means it's going to go this way. Because if you think of it, if you put 0 in, 0 is greater than negative 4, so we got to go this way. So that's how you graph it. Solid circle. Let's look at example 2. Oh, core concept first, sorry. Subtraction is going to be the same. Just like when we can add something, we can subtract something, and it's still equal. So if we're looking at this, I can do the inverse of adding 8, which is subtracting 8. Oops. Minus 8. Whatever you do to one side, do to the other. So that's going to cancel those out, and I'm left with just y over here is less than or equal to 5 minus 8, which is negative 3. So when we're looking at graphing this now, let's say this is negative 3, negative 4, negative 2, negative 1, 0, 1, 2. We're going to be looking at this. Again, it's going to be a solid circle because it's less than or equal to, it's got the equal sign underneath, negative 3. So I'm going to put the dot at negative 3. Okay, now we've got to decide. Y is less than negative 3. See, if I put in negative 4 is less than or equal to negative 3, that's true, but if I put in negative 2 is less than or equal to negative 3, that's not true. So we know that the arrow needs to go this way. Now let's look at this one. Solving this one here. Just because it's on the different side doesn't mean anything. Remember, that is a positive 1.4. So to get rid of it, because we want to get away from the m, that's subtracting 1.4. So again, subtract 1.4 on this side too. Those will cancel. We're left with just m. Keep the sign. And negative 8 minus 1.4 is going to give us a negative 9.4. So now when I go to graph this, I will just make this negative 9.4, negative 9.3, negative 9.5, and you could keep filling those out, but okay, we're looking at negative 9.4 is less than m. So 9.4, it's an open circle because it is not equal to that. So it's less, m is greater than negative 9.4. Well, let's just try a couple numbers out. Negative, well, let me just put in 0 here. Negative 9.4. Remember, 0 is going to be somewhere down over here. Is that less than 0? Well, yep, that's true. So we know the arrow is going to go that way. So now let's look at modeling with mathematics. A circuit overloads at 1800 watts of electricity. You plug a microwave oven that uses 1100 watts of electricity into the circuit. Write and solve an inequality that represents how many watts you can add to the circuit without overloading the circuit. So first you need to understand the problem. You know that the microwave oven uses 1100 watts out of a possible 1800 watts. You are asked to write and solve an inequality that represents how many watts you can add without overloading the circuit. You also know the number of watts for the 4 other appliances. So we need to make a plan. We're going to use some verbal things here. We're going to have watts used by the microwave oven plus additional watts has to be less than the overload. So watts for the microwave plus the additional watts has to be less than the overload. Okay, now that we've got that figured out, we can just write that out. Okay, we're just going to have W be the added watts. So the microwave uses 1100. The added watts, we'll say, is W, has to be less than the 1800 that the circuit overloads on. So now we have our equation. And now we could also simplify that so we know exactly what we have. So if you look at this, I can subtract 1100 and I will get those cancel out. W is less than 700. So now when we're looking at part B now, in addition to the microwave oven, remember W is less than 700, which of the following appliances can you plug into the circuit with the same time without overloading the circuit? Can I do a clock radio? Well, yeah, it's only 50. Could I do a blender? Yep, it's 300. Could I do a hot plate? Nope, that's greater than 700. What about a toaster? Again, greater than 700. So you can only run the clock radio and or the blender. You could run both of those at the same time as in addition to the microwave. But the other two, the hot plate and the toaster, you could not. So finish your notes and bring them up to me to check them off and do your clever assignment.